In my previous video, I have introduced the concept of limits. We will now apply this concept to find the slope of a line tangent to the curve at a certain point. So let's first review the slope of a straight line. So for example, we have y is equal to x over 2 plus 3. And as with the new protocol, instead of y, we will be using the function of x is equal to x over 2 plus 3. So let's just plot 2 points. So instead of y, we will be using f of x. So we won't be using this one anymore. F of x. For example, we have if x is 0, then 0, so like you write it as like this, 0 over 2 plus 3. Your function of x is 3. If x is, let's say, 4, the function of x is 4 over 2 plus 3. 4 divided by 2 is 2 plus 3. So if your x is 4, your function of x will be 5. So let me plot this one. So we have your x and y, and then so 0 and 3, so 1, 2, 3. So if x is 0, your y is 3, so this is the point. If x is 4, 1, 2, 3, 4, your function is 5, so if this is 3, 4, 5, so this is your line approximately. Now if you want to get the slope using these 2 points, so the slope is y2 minus y1 over x2 minus x1. So this is 0, 3, this is 4, 5. So y2 minus y1, so this is x1, y1, x2, y2. So 5 minus 3. 5 minus 3, and then x2, so 4 minus 0, 4 minus 0, 4 minus 0, so this is 2 over 4 or 1 over 2. So your slope is 1/2. It means that this is your rise, this is your run. So it means that for every 1 of rise, there will be 2 runs. So 1 is to 2, so 1/2. That's your slope. So now this is good, regardless of where you put your points. So for example, in here, the slope would still be 1/2. So the whole line, the slope is the same because it's a straight line. The slope is always 1/2, 1 rise and 2 runs. But for a curve, each point in the curve will have a different slope if you draw a tangent line on it. So let's take an example, this equation, y is equal to x squared. So let's use x and y for now. So x and y. So if your x is 2, so if you put 2 here, 2 squared is 4, so your y is 4. If you put if your x is 4, so you put 4 here, 4 squared is 16. if you put 6, if 6 squared will be 36, and then if you put 10, if you put 10 in here, 10 squared is 100. So let me, if we plot it here, so I'll just use a different scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say this is 100. So this each is 10 to 100, and but in here I'll just use single units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say, let's plot this 2 and 4. So your 2 will be here, but your y will be like this is half is 5, so your 4 will be slightly lower. Actually, if x is 0, 0 squared is 0. So there's a first point in here. This is a parabola, by the way, so opens upwards. We plot 4 and 16. So 1, 2, 3, 4. Your 16 is, this is 15. So your 4 will be slightly higher than 15. So this is your 4 and 16. Your 6 and 36 is 1, 2, 3, 4, 5, 6. This is 6. Your 36 is 10, 20, 30, 35. So 36. It's slightly here. And then 10 and 100. So this is 10. This is 100. So it's approximately along this line. So the curve is like, is a bit, yeah, this will be your curve. Now if you want to get the slope of this point is 2, 4, and then this is 4, 16, this is 6, 36, this is 10, 100. So you want to get the slope of this point. So the slope in here is around, it's almost flat. Now we can start getting the slope with 110. We can get the second line. Second is a line passing through points in a curve. So if we get the slope of this one, what you will have is 100. So the slope is, so the slope of this one is y2 minus y1, 100 minus 4 over 10 minus 2. So 100 minus 4, 10 minus 2. So that would be 100 minus 4 is 96, 10 minus 2 is 8. So your slope is 12, or 12 over 1. So this is your rise, this is your run. So approximately this slope is, it will have a 12 rise for 1 run. So that's 12:1. Let's say we want to get the slope of this one, 630, this from 636 to 24. So it will be this one. So what will be your slope? So the slope on that point will be 36 minus 4 over 6 minus 2. So that will be 32 over 4, which is 8. So this one, it has a it has a rise of 8 for every run of 1. 8 over 1. So now let's get the slope from 416 to 24. What is the slope of 416? So that will be 16 minus 4. So please bear with me. Just want to see the trend. I just want to show you the trend. So 12 over 2, 6 or 6 over 1. So from here to here, the slope is so the slope is getting closer and closer to the point that we want. So now it's 6. How about, like, we want to be as close to 2, 4 as possible. So let's say I'll add another point, 2.1. So if you square 2.1, that's 4.41. So let's get the slope of that one. So the slope of that one would be 4.41 minus 4 over 2.1 minus 2. So that would be 0.41 over 0.1, which is 4.1. So it's very, very close to 2.1. Let's make it much closer. So 2.01, this is very, very close to 2. So if you square that, your y would be 4.0401. What would be the slope? So the slope at that point would be 4.0401 minus 4.0 over 2.01 minus 2.0. That will be 0.0401 over 0.01, which is 4.01. So as we get closer and closer to this point, the slope gets closer and closer to 4. And actually, the slope at this point is exactly 4. So you can see that we can establish that the slope at 2, 4 is 4. But we cannot use the same point if we like get the slope on the same point. So 4 minus 4 over 2 minus 2, that will be 0 over 0. We cannot use the same point. So we have to get a point very close to that point to establish the limit, or how close it is to the limit, which is 4. So the actual slope is 4 at 2, 4. Using the analogy that we have just discussed, mathematicians are able to come up with a formula for computing for the slope at any point along the curve. So I will just rewrite our curve and magnify at the same time. So this was our curve. Now this is, let's say this is 2, 4 earlier, and this is the 2.01, 4.0401. So these are your 2 points. And then, so earlier we took we were able to get this slope, so which is 4. We got the value of 4.01, which is very, very close to 4. Now we can now derive a a general equation, so we can generalize this one. I will rewrite it again and generalize. Let's say this is your curve. So let's say this is your x. This is your xy, but we don't use the y, we use the function of x. This is your x function of x, and this point is, let's say, see this difference from here. This is 2. This length from here to here is 2, but the length from here to here is 2.01. This is 2.01. This is 2.01, 4.004. Now that is a 0.01 length. So let's assign a letter, let's say h. So that h is very, very small, microscopic, let's say 0.00001 small. Now this point, so because this is from here to here is x, and from here to here is h, so your point here is x plus h. This is your first point. Your second point is a function of this point, so this is a function of x plus h. So just like here, this is x and this is a function of x. So if this is x plus h, this is a function of x plus h. We now get the slope of this general equation. So the slope is y2 minus y1. This is our original slope. x2 minus x1. But we will be using these numbers. So instead of y2, your y2 is this one. The function of x plus h minus the function of x, so my y2 minus y1, so function of x over x2. Your x2 will be this one, x plus h minus this one, which is x. So your slope now is this one. X minus x will cancel out, leaving only h. So we will write this one and then change the denominator. So f of x plus h minus f of x is h. Now this is your general formula to get the slope of the curve at any point in the curve. They call this the difference quotient. Difference quotient. Okay. They also call it f prime of x or derivative. But yeah, whatever you call it, it's the same. Now, we can try to get examples and use this difference quotient to get the slope at any point in the curve. Example 1, the first example, we will use the previous curve to get the formula, the general formula for the slope. So the derivative or f prime x for this curve is, I will rewrite the function first. So for x plus h minus function of x over h. So what is the function of x plus h? So the function of x plus h is, you will replace this x plus h, you will place it inside of x. So what will happen for the function of x plus h? So you'll replace it in to go inside. So this will become x plus h squared. So whatever is the value here, you plug it into x. So your x is squared, so your x plus h becomes squared minus, so whatever, the function of x is x squared, so minus x squared. So function of x is x squared over h. So you have to multiply x plus h times x plus h. So let's say x plus h, x plus, I keep writing h, x plus h times x plus h, x times x squared plus xh plus xh plus h squared. So x plus h squared is x squared plus 2xh plus h squared minus x squared over h. Now x squared minus x squared, it will cancel out. So what you have left is 2xh plus h squared over h. Now on top, both terms have h, so we can factor out h. So this h, 2x plus h, and then over h. Now h and h will cancel out, so your general formula will be 2x plus h. This is your derivative. But if you would remember, so this is your curve, this is your 2 points, this is your h. So actually your limit as h approaches 0 will be this point. So this will be 0 because this is really, really small, and we want it 0 so that it will be on the same point. So your general formula for slope is 2. This is your general formula for slope. Now, what is 2x now? So let me draw for you this curve. This curve is, let's say, x and then f of x. So this is a parabola going upwards. So if x is 0, fx is 0, I'll just use the positive. If x is 1, fx is 1. If x is 2, you squared it, it becomes 4. If x is 3, you square this one, it equals 9. So let me plot this. Let me plot this line. So I'll shorten the y-axis, so make it fit 1, 2, 3, 4, 5, 6, 7, 8, 9. I can, but this one I can make it longer. 1, 2, 3. So 0, 0. This is this one. 1, 1 is this one. 2, 4. 1, 2. So 1, 2, 3, 4. So this is your curve. 3, 9. So 1, 2, 3, and then 9. So this is now your curve. Now, so I have plotted 3 points. So if you want to get the slope at this point, this is 1, 1, 1, 1. What is the slope at 1, 1? So your x is, this is your x, This is your function of x. So your x here is 1. You just replace your x with 1. So 2 times 1 is 2. It means that at this point, your slope is 2. It means like the rise over the run is like 2 and 1. Let's say we want to get the slope at this one. This is 2, 4. 2, 4. What is the slope at point 2, 4? So you use this one. This is our general slope. You replace x with 2. So 2 times x, which is also 2. Your new slope will be 4. So at this point, your slope is equal to 4. If you can remember our example, we were trying to get as close to 2, 4 as possible, and the limit approaches 4, and it's actually 4 at that point. Let's say this is 3, this is 3, 9, 3, 9. What is the slope at 3, 9? We just plug the node 3, this is your x, in here. So 2x is 2 times 3. This is 6. So the slope at this point, your slope is at 6. So that's so yeah, each point has a different slope, and using this general formula, we can get the slope at any point, and we were able to get this because of the formula that we have, the difference quotient, which is this. We use this. Example 2. The curve is the function of x is equal to x squared minus 4x plus 1. So again, we will follow this formula. I might as well write it. F of x plus h minus f of x over h. So this is your f prime of x, or this is your derivative formula, or quotient, difference quotient. Now, so what will happen is, for the function of x plus h, you will replace all the x's with x plus h. So function of x plus h, so this one, x plus h squared. So yeah, we replace this one inside of this one. Minus 4, instead of x, we put x plus h. X plus h plus 1. So minus the function of x. The function of x, this one, I'll try to fit in. I've used too much space. So the function of x, we just copy this one. So that will be, we just copy this one because that's a function of x. So that will be x squared minus 4x plus 1. And all over h. So we have to multiply x plus h by itself. So that would be x squared plus 2xh plus h squared. So this one we have to distribute. Minus 4x minus 4h plus 1. So we have to subtract. So we have to again distribute the negative sign. It will change the sign of all of them. So this one becomes minus x squared. This becomes plus 4x. This becomes minus 1. So there's a lot of cancellation. So x squared and x squared cancels out. Negative 4x and 4x cancels out. Plus 1 and minus 1 cancels out. So what do we have left? So 4h. And yeah, so we have all over h. So what we have left is 2xh plus h squared minus 4h all over h. So all of the terms on the numerator have h, so we can factor out h. So what will be left is 2x plus h minus 4 all over h. And this will cancel out. So what you have left is 2x plus h minus 4. Now, like I said before, like the h is so small that we would want it to be 0. So we're getting the limit as h approaches 0. So the general slope formula is 2x minus 4. This is your formula to compute for the slope at any point in the curve. Let me draw this this curve. So x plus y. So if your x is 0, let's say 0. So 0 minus 0 plus 1. So your y is 1. If your x is 1, so 1 squared. Let's compute that one. 1 squared minus 4 plus 1. So that will be 2 minus 4 is negative 2. So I'll just write all the values. You can check for my computation later. 1, 6, 2, negative 3, negative 2, 13, 3, negative 2, and 4, 1. Now if we plot this in here, let's say 0 and 1, 0 and 1, 1, negative 2, so 1, negative 2, negative 1 and 6, negative 1 and 6, 1, 2, 3, 4, 5, 6. 2 and negative 3, so 2, negative 3, negative 2 and 13, so negative 2 and 13, so it's way above here. 3 and negative 2, so 3, negative 2, 4 and 1, 4 and 1. So it's also a parabola pointing upwards. 4 and 1. So basically this is your. So for example, you want to get the slope. Yeah, we'll just use so this is 1, this is 1, the x is 1, so you want to get the slope of this one. This is x equal to 1 at this point. That's x. This point is 1, negative 2. So what is the slope at that point? You just substitute. This is the value of x. X is equal to 1. You just substitute it to here. So that will be 2 times 1 minus 4. So your slope will be 2 minus 4 is negative 2. So at this point, your slope is, this one is negative 2. The slope is so the rise is, so this is 2, but this is negative 1. So this is your slope at this point. Well, how about this one? This is 1, 2. So if your x, so this point is 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2 2, negative 3. This point is 2, negative 3. Let's get the slope at 2, negative 3. So this is your formula, 2x minus 4. You substitute 2, the value of x, in here. So 2 times 2 minus 4. So 4 minus 4 is 0. It means your slope in here is exactly horizontal, which means your rise over the run, your rise is 0 over the run. So it will be horizontal. There's a 0 rise. There's no increase. So your slope at that point is 0. And then let's say this one is 1, 2, 3. So this point is 3, negative 2. This is 3, negative 2. So we just plug in the value of 3 to here. So 2 times 3 minus 4. So 2 times 3 is 6. Minus 4 is 2. So in here, your slope is 2. It means your rise is 2 and your run is 1. Yeah, and so on and so forth. So this is your general formula to find the slope at any point in the curve. Example 3. The function of x is equal to 2x plus 3. So let me write the equation first. So to get the general slope, x plus h minus the function of x over h. So this is your function. So we will put x plus h inside x. So you copy this one, except that for h you will write this one. So 2x plus h plus 3. So that's your function of x. This is the function of x plus h minus the function of x. So function of x is this one. So this is be careful, you have to put it in parentheses, 2x plus 3. If you don't put the parentheses, the negative sign will only go to 2 but not to 3. So be careful with signs all over h. Now we have to distribute 2x plus h. So 2x plus 2h, this is 2, sorry, plus 3, and then we distribute the negative sign, minus 2x minus 3 all over h. Now 2x and 2x will cancel out, 3 and 3 will cancel out. What you have left is 2h over h, and then h will cancel out. So your slope is 2. Where's the x? There's no x. Let me draw this line. I'll just use the slope-intercept form. The y-intercept is 3. So 1, 2, 3. So this is your first point. Your slope is 2 over 1. So there will be a rise of 2 and then a run of 1. So this is it's a line. Now your slope is 2, there's no x. It means that your slope will always be 2 regardless of where you get the point. It will always be 2 because it's a line. The slope will be the same all throughout, but we were able to get the slope using the quotient difference quotient. Example 4, the function of x is x cubed. So I'll just write the formula, function of x plus h minus the function of x over h. Now this x plus h we will put inside here. So what will happen will be x plus h cube. Cube. So whatever is in here, you plug it into x. But x, this one is cube, so we have to put cube. Minus the function of x, which is x cube. Now we have to multiply x plus 8 by itself 3 times. So let's do it the long and hard way. I'm old school, so this will be x squared plus 2xh plus h squared. xh is 2xh. And then we have to multiply again by x plus h. So x times x squared is x cubed. X times 2xh will become 2x squared h, and then x times h squared will be x h squared. I just want to check my maths. 2x squared h, x times h squared, x times, yeah. Okay, now we go to the second term. H times x squared will be h x squared. So this is here, x squared h, just one. H times 2xh, so that is here. That will be 2xh squared. And then h times h squared is h to the third power, or h cubed. H cubed plus 3x squared h plus 3xh squared plus h cubed. By the way, you can use the Pascal's triangle to compute h plus x cubed, but I prefer it this way. I make mistakes on that Pascal's triangle. Anyway, so this one becomes this one. I'll just make more space. So 8x cubed plus 3x squared h plus 3x h squared plus h cubed. So this is x plus h cubed minus x cubed all over h. So what are the things we can cancel? So x cubed and x cubed, negative x cubed. I think that's it. Now these three terms, they all have h. So we will factor out h. So this 3x squared h will become only 3x squared. Wait, our h, I forgot the h. So you remove one h, what you have is 3xh plus, you remove one h, you get h squared. Yeah, now over h. So you can cancel h. So what you have left is 3x squared plus 3xh plus h squared. So this is now your quotient, difference quotient, whatever. Now, as I mentioned, your h approaches 0. So what is the limit approaches 0 as h approaches 0. So this one becomes 0, this one becomes 0. So your slope will be 3x squared. Now let me plot. So to plot, of course you have your x and y. So if x is 0, assuming x is 0, then your y is 0. If your x is 1, 1 cube is 1. If your x is negative 1, negative 1 times negative 1 times negative 1 is still negative 1. If your x is 2, 2 times 2, 4 times 2 is 8. If your x is negative 2, negative 2 times negative 2 times negative 2 is negative 8. So let me just draw this one. So at 0, 0, your point is here. 1, 1. So 1 is this one. Negative 1, negative 1. So negative 1, negative 1 is this one. 2 and 8. So 2. 1. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 2, this one, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is your point. So your curve is actually like this. So this is your curve. Now let's get the slope in here. This is 1, 1. So this is your x. So you replace x with 1. So that will be 3 times 1 squared is equal to 3. So the slope in here will be 3. So the rise is 3, your run is 1. Let's get the slope at 0, 0. So if we replace, so this point is 0, 0. So your x is 0. You replace x with 0. So 3x squared. So 3 times 0 squared is 0. So it means that this one I will magnify. So your curve will be like going like this, and at the exact point it changes direction. So at the exact point of 0, the slope is 0. Your slope is 0, means your rise over the run, this is your run, your rise is 0. So it's exactly horizontal at this point. Let's get this value. This is 1. This value is negative 1, negative 1. This point is negative 1, negative 1. So this is your x. So we substitute negative 1 here. So that will be 3 negative 1 squared. So this will become positive. Negative 1 is 1 times 3 is 3. So it means that in here, your slope is positive 3. So it's going this way. So it means that your rise is 3, your run is 1. And that is the end of derivative. So I would like to request that I'd like to ask for feedback on if I'm able to explain this derivative. Please leave a comment below, and because I'm really hoping that this can make you understand the derivative, because this video is the heart of differential calculus. Once you understand this is the main topic. So once you understand this, differential calculus will be easier, because this is like the long method. This is how you will understand, but there are shortcuts. Like, see, this is your function, and this is your final answer. And the shortcut of this is this one goes in the front, and then you subtract 1, and that's your shortcut. So I would like to explain it this way. I don't want to explain the shortcut that this one goes here. So 3 goes to the front, so 3 goes to the front of x, and then you subtract 1 from 3, becomes 2. So this is your general slope. So there are a lot of shortcuts that eventually I will be able to teach, and other types of curves that may be difficult to differentiate. So I am requesting for your feedback. If at any point what part is not clear, which parts are clear. Thank you very much.